the only person who has attended all of the summer schools. Someone can object if they want. The topic of this session is that I would, so to say, duplicate Inari's talk this morning, which will not be quite precisely like that, as we will see. But there was also, in particular, something that was that Inari forgot to say at the beginning of her talk, which was to introduce herself. So let me do that. So you can all see Inari's picture and her very short about document. I'm not reading that, but I would say that Inari is kind of chief linguistic officer of the Digital Grammars company, where I am one of the founders of. She has been maybe the key contributor to the GF resource grammar library in the recent times, and she has in that in addition to that, so she has worked with the computational law applications in Singapore, or maybe of course mainly on that, but these things can't be completely separated from each other, because as you will see, the resource grammar library is something that it's the key thing is to for everything is to expand the set of languages, and Inari has done that for great many languages, and she will always learn a new language if you just ask her to do that and give her the support. So Inari has been around, as far as I know, since 2010 in the GF community, and yeah, contributed in several different ways, and not to forget her PhD on the combining GF with formal methods for checking grammars. Inari is also very talented in music, in choir, both conducting and singing, and also composing for musicals and all kinds of things that you might also hear if you prompt her. And the last thing to mention is that maybe you have already guessed, but Inari and me have a secret language in common. So if we don't want you to hear what we say, so I can say, for instance, Inari, mitäs jos mentäisiin kaljalle tämän luennon jälkeen?
Eikä lentää koko aikana. Okay, thank you for the introduction. So
you can add something what you want.
Yeah, no, that was very comprehensive. So let me return the favor. And
let me share my homepage so you can.
Yeah, you can share. I didn't have it prepared. Okay, so right. So Aarne is the creator of Grammatical Framework. So he's been around since 1998 in GF, and like, and certainly a lot of things before that, like that were the inspiration to creating GF. So Aarne, when Aarne was young, he wasn't sure if he preferred mathematics or languages. So that's why he created GF, because why not both? On his spare time, so Aarne likes to go hiking on the mountains, and in fact he also used to sing in a choir and played a recorder. Yeah, and he's the CEO of Digital Grammars, where I also work. So yeah, I think we can let the presentation.
Yeah,
do more.
Thank you, Inari. Nothing to add to that. Let me then go to the first set of slides here, or actually the only set that I will show today. here. And now I will make it presentation, and I hope this still works flawlessly. So the GF ecosystem is the bold name we use for all things GF. If someone asks what GF is, so there are very many answers, and I will actually show boxes with each of these answers. We will see, first of all, it's a programming language, but then it's also many other things, and altogether these form the ecosystem. So the mission of GF has always been and is still to formalize the grammars of the world and make them available for computer applications. So we want to write formal grammars, and we want to be multilingual and even globally multilingual. And then we want everything to work in computer applications, so that this is not just a theoretical exercise, but something that is useful for something. And of course, this is a lifetime challenge, not only for one person, not only for 300 persons, but yeah, this is a bold thing. The challenge is that, and this is something that we have to meet in particular when we discuss with others who maybe know something about natural language processing. So there is this conception of computational grammars, which is partly true, that they are very demanding. So you need a PhD in linguistics in order to do anything useful, which requires 5 years of work. Still, you get something which only has a limited coverage, and it's very brittle, so it breaks when you try it at real world language, and therefore it's an obsolete technology. Whereas statistics and machine learning, neural networks, whatever is the current trend there, you can get productive with just a bachelor's in computer science, which is maybe 100 times more common than PhD in linguistics, or even more. So it's easier to find people to do this. Instead of 5 years of work, you just wait 5 weeks for learning to crunch through the numbers. And the result is something which is wide coverage, which is robust, and which is therefore state of the art since maybe over 20 years right now. And this is a challenge we have to meet when we say we have to kind of defend ourselves why we are making grammars, instead of just doing what the mainstream in natural language processing is doing. And so if we think about what the secret of statistics and machine learning is, that it kind of eliminates human work. So you let the machine learn language, including things about the grammar, automatically. And this is economical if you think about the practical use in natural language processing. And in GF, so we take a bit of an other approach. So the problem here was that it requires a lot of work and a lot of expertise to build anything with grammars. And what we want to we have to admit that yes, it does take a lot of work, but we don't need to eliminate it all, and we can't even hope to do it. There are things where you need human input and human interaction, but we want to make it as easy as possible, so that actually, and this is, I think, the summer schools have been a proof of that. So someone with a degree equivalent to anything between bachelor in computer science and PhD in linguistics, or even beyond that on both ends, will be able to do something which is can be done in a couple of weeks of work, for instance, during the summer school. What comes to wide coverage and robustness, so that can also be done to some extent, but we are actually, as I will show, are more focused on things where precision is more important than coverage. Whether it has anything to do with state of the art, so I think GF is to some extent has reached the state of the art status in some niche applications such as natural language generation and controlled natural languages. More about that in a while. Also in some work with under-resourced languages where the data available for machine learning is not sufficient. By the way, you are welcome to post questions at any point if you want. I'm not able to follow the chat while I'm speaking, but I will of course look at it later. But if you have questions, so please go ahead. So the access to GF is of course via its web page. And if you have one description of what it is, so we say exactly that it's a programming language for multilingual grammar applications, or maybe to be more precise, multilingual grammars and their applications. And you will get familiar with all of this, what is behind most of these links, so I will not go to them right now. But first, this functional programming language aspect, and there is a theoretical and computer science background to GF, so that it's actually designed as a functional programming language, and the functional programming languages have this very reputation that they can reduce human labor by powerful abstractions, so that you, as some of the legends say, so you can write a program with just 10 times less lines of code than what you would do in a more imperative programming language. Well, I don't know if that's how true that is. Then there's also the reputation that functional programming languages are a bit harder to learn and not very popular, and that's maybe also true. But anyway, so the inspiration of the GF programming language is from there, and the first inspiration for me personally, before starting with GF, was ALF, another logical framework. So actually, logical framework is the background, and GF is like logical framework plus grammar, and the bold name grammatical framework also comes from this history of it. But then there are more mainstream, if there is anything that is mainstream here, functional languages, Haskell, and before that ML, which were inspirations. So many features of GF come from those, although it must be stressed and time and again that GF is not the same as Haskell or ML, but it's a language of its own, only that it resembles Haskell in many ways. Personally, one inspiration was also XFST, the Xerox finite state tool, because when I started GF, I was working at Xerox, and there the finite state tool was very prominent at the time in '97 and so, and it was actually a proof that you can do something which is wide coverage and robust even in a rule-based system. So this we should keep in mind, that XFST was kind of the first really scalable approach to computational morphology, and they also did shallow parsing and things like that in a completely rule-based manner. Compilers is another technology that is behind GF. So one would say that GF is like built as a compiler for natural language, where you can think that if you are doing translation, for instance, then when you translate from English to Chinese, let's say, then English is the source language and Chinese is the target language. in the sense of how compiler is translating source language to a target machine code. So that's the architecture of GF. But so it was from the beginning important to be multilingual. So the GF grammars support many languages, not separately like XFST did, but in parallel in one and the same system. Then GF was meant to be reversible. That was somehow, to some extent, a heritage from other work on computational grammars, where the important thing was to have a declarative grammar formalism, which supports for both generation and parsing. That's what reversibility means. So you don't need to write separate rules for generation and parsing, but you write one set of rules and they can be used in both directions. Modular is yet another feature which is important when you deal with large grammars, and it becomes immediately important when you want to deal with several languages at the same time in parallel, but then there is something that is shared between them. So the module system is one of the important things, and which is inherited from ML rather than Haskell, although much else in GF looks more like Haskell than like ML. So this architecture is what we would traditionally call interlingual translation. So there is an interlingua in the middle, and then the languages, the individual languages are related to the interlingua. And when you want to translate from one language to the other, then you just go to the interlingua and then from the interlingua to the other language. And these double-headed arrows mean that these grammars are reversible. And this is, of course, like in interlingual machine translation when you work on such applications, but you can also think of other applications where you actually start from the interlingua and then you, for instance, in natural language generation, and then you go to the different languages. So we will see all possible combinations of that during the summer school, but and you might have some of your own applications in mind. But then what the effect of this is, if you think again about the translation, is that by writing these modules, I think I have 14 languages here, plus the interlingua, so I have 15 modules here and 14 arrows. So you get actually a quadratic number of arrows going from one language to the other. So this makes it scalable in a linear fashion. If you add a language and you want to translate that still to all the other languages, so then you only need to add it once and not have separate arrows for each of the old languages. So that's the GF programming language and what it's meant to do. So it will support these interlingual grammar systems. There is a theory behind it. So I mentioned logical frameworks, and logical framework is the same as, almost the same as type theory in the sense of constructive type theory or intuitionistic type theory, or something that you barely can read here, Per Martin-Löf. So it's also called Martin-Löf type theory, which is used in things like computer mathematics and program verification. And that was the background of GF, and before there was GF. So when I was working on my PhD in the late 80s, so I wanted to combine the ideas of type theory with the grammar architecture of Montague, so-called Montague grammar. And the result was then later after the PhD, so I wrote a book about this entitled Type Theoretical Grammar. That was a kind of an ancestor of GF. So that's the abstract syntax, the interlingua part. Then the concrete syntax, how you actually process language, parse and linearize it. So that's based on a formula is called PMCFG, Parallel Multiple Context-Free Grammars. And the foundation of that was laid in Peter Junglöv's thesis in 2004, and then this was kind of continued and developed further by Krasimir Angelov in his thesis. And they also wrote a paper together, which then combined this with statistical probabilistic grammars. The PMCFG itself is known from 1990 by the work from Secchi and others, and it does play some role in the theoretical formal linguistics as a powerful but still polynomially processable grammar formalism. Okay, then something kind of, if you feel that you are a bit lost in all the technical details by now, so we go to something more concrete, which is the languages. And we have the already mentioned resource grammar library, which was actually has been boosted by the grammar schools quite a lot, especially in the beginning. Now there are kind of the coverage of languages you can see here. So we are covering many of the large languages, and we are going to more of the under-resourced languages. So the green ones are kind of the complete ones in a sense that it will become clear later. The yellow and orange ones are in different stages of progress. And maybe as a result of this summer school, so we will have more languages here on the world map of GF languages. So the resource grammar library is available as a programming library. So it provides an API, an application programmer's interface, in which you can pick grammar rules, and then with those rules create functions that generate and parse different languages. And the languages have the same API, so or to a large extent they have the same grammatical structure that is imposed on them. So here we have the documentation for one of the functions, which is v2. So it's okay. So it's the function on the top here. She loves him, and then the API documentation shows how it is translated to all of the RGL languages that are complete enough to support this. None of this would be possible without the community. So building the community has been one of the both challenging and in particular pleasurable parts of GF. So we have all of the code that is kind of relevant, so to say, that is not that we will show here in the summer school. For instance, it is available in the GitHub, in the repositories, for instance, the resource grammar library, RGL, and the core library. And you can see that there are an interesting set of contributors here, and thousands of commits from people. I should also stress that this GitHub only started a few years ago, and there is a prehistory where more contributors were writing code that is whose origin is not necessarily visible in GitHub anymore. Because this has been built ever since 1998. There's the Google group that has kind of constantly have about 200 to 300 members. Maybe its significance is getting lower because we have other channels, just as such as the IRC and then the GitHub discussions and the Discord that we have on this summer school and so on. But if you want to be a part of the kind of longer term community, so it's still a good idea to join this group, GFDev. So to all of this, to support all of this work, GF comes with a number of tools. The most straightforward tool is the GF shell, which is used for in the same way as, for instance, Python shell or Haskell GHC, interactive GHC, to experiment with grammars with various commands. So import grammars and then generate random trees and linearize them and so on. We'll see much of that already a bit later today. But we will actually start with GF Cloud Service with some web applications. So the idea with this is that you can get, start using GF without having to install anything except the web browser that you already have. So I will, in my tutorial part after the ecosystem, so I will mainly use the GF Cloud plus the GF shell. But there's also another development tool, which is a Jupyter notebook kernel, which Inari gave his tutorial about. So if you rather use the Jupyter notebook, or you would like to use it so you can watch Inari's tutorial from this morning, well, morning at least Singapore, and very early morning Swedish time. But if you are not in, so when you want to deliver applications that are built on GF, so you don't, of course, expect your users to have these development tools, the shell or the notebook or something like that, but you want to build some host programming in some other language. And that's why we have different runtimes for GF, with which you can build applications in, for instance, Haskell, C, Java, Python, JavaScript, and then also Android and iOS applications. So I think during this course, we will mainly, at least I will, when I'm showing applications, so I will show them in Python and some in Haskell. So here is the part of the documentation for the Python binding API. I will also come back to that probably next week. So these tools enable different applications, and the most straightforward application is translation with a controlled natural language. So you have a language that is defined by a GF grammar, and then you use it for translating, in particular in applications which require precision and maybe have some technical or scientific content. Not necessarily, but that's a typical application where you want to have a grammar and not just some machine learned algorithm. So this example is a bit early, but it's from the project that I think Jan Fredrik will talk about next week, about mathematical language translation. This is another application that we built some years ago in digital grammars for the use of ambulance staff for communicating with patients which didn't speak any language in common with the ambulance staff. And this is another example of something which is kind of a limited domain, but the precision is very important, that you get it, that you know exactly that the translations get right. Conceptual authoring is a way that to use this grammar in order to create text or other or documents or something without knowing GF, so to say, but defining the concepts of what you want to say. And this was built by Michal Mechura, who will maybe talk about this or related things later in the summer school. We also tried to work with wide coverage translation, and that's still on the agenda. So this was the iPhone app from around 2015, where we had a kind of a precision grammar and that gave us green translations that we were sure about. Then yellow translations were given by a wide coverage grammar, but we were no longer as sure about the translation. And then the red translations were kind of backup given by splitting the input into small bits or chunks. So the technology is still there, and I think one could rebuild this, but we, yeah, the people who were developing this wide coverage translation in a kind of a product that was the mobile application. So we kind of didn't develop it for some years, and then we just took it away from the App Store and Android Play Store because it looked obsolete to us. But of course, it's something that is still a relevant thing to try and develop. Although, so it shows that you can do something which is has an unlimited coverage, but it's a lot of work. And if you are doing unlimited translation, then neural translation is nowadays so good that it's quite hard to compete with that. Please disagree with this discouraging conclusion. So after this excursion to this wide coverage, robust applications, we were kind of been coming back more to this precision demanding applications. And here is an example of from the GDPR, the European Data Protection Law concepts that were built in the Digital Grammars company together with another company, Signa2, on computational law. And the target here was to find different, for different languages, the exact renderings of key concepts in the law. And a demo of this shows a kind of a lexicon of these concepts, but behind this demo, there's actually a grammar that can inflect these terms and also use them in all kinds of grammatical combinations. So there were about 3,000 such concepts that we found in this official document. And the interesting thing here is that you see immediately that you can't do this translation word by word, but the words can have, the same word can have different translations in different languages, but also this depends on the context where the word is put. So here you can see, for instance, that subject is sometimes an subject and sometimes an object in another language. Quite interesting. So more generally, then we have worked on natural language generation, both in digital grammars and in, of course, in many other projects by other people. So here is a typical example of converting formal language to natural language, which was done with the Altran company in the UK. So this is a Z specification language for big systems that they use, and we generated English from that. There have also been projects on language learning applications where computational grammars are being used for training grammars, for training grammar and training a foreign language. A bit like in Duolingo, but in a more grammar-aware way. Question answering, both in kind of control language setting where you have query language like SQL, and it's a GF grammar, or you can have something more worldwide, like here, a project for finding answers on the World Wide Web to open domain questions. Dialogue systems where you communicate in speech. So this is an example from a master's project in Gothenburg with the Saab company on voice commands for a radar system. So I already mentioned some companies that have been building these applications, and digital grammars is one of them. Another one is textual. And textual is, so digital grammars is very much working on different applications of GF, because we have some of the core developers of GF on board, for instance, Inari and me. And we also have Krasinger and John, who will perform later during the summer school, and Arianna. So anyway, we will, yeah, so that's what digital grammars has been doing. But then there are companies that are more focused. For instance, textual is very focused on e-commerce product descriptions generation in different languages. Tokamak is focused on spoken dialogue systems. There is another natural language generation company who will, I think, appear here. That is more recent, accelerated text. And here we have a list of some other companies that we know of. So it is companies, applications, tools, community, but there is also some ongoing research. So some of GF is already mature for business and production, but there is of course more research going on. One challenge here is that we are working in this segment of precision language processing. So if you think about a natural language processing, or maybe also some other artificial intelligence applications, so there's a trade-off between precision and coverage. So you cannot at the same time reach full precision and full coverage. But for instance, in machine translation, like Google Translate, the typical direction is that you want to have a full coverage from the beginning and then maybe improve the precision. Whereas in GF, we have opted for the precision more than the coverage, and then of course have ambitions to grow the coverage. A typical use case for both of these is can be called producer tasks versus consumer tasks. So a consumer task is when you are reading a web page in, let's say, Chinese, and you want to see it in English. So then you send it to Google Translate, and you can get something which shows you, gives you an idea, or maybe even a very good idea of what is in English. There can be some small errors. There can be some bigger errors, such as leaving out a negation from some sentence so that it comes to its opposite. But you know that this is very useful. So that's a consumer task. You as a consumer are reading someone else's content through the translator. And this requires high coverage because the consumers can just throw anything at the application. Whereas a producer task, you want to have high precision. So if you are, for instance, an e-commerce company and you build pages for your product, so then you are responsible for the content that you are publishing. So you can't just drop a negation because you can be sued for that later. But on the other hand, it's enough to have a lower coverage, and that's where GF excels, one would say, to build precision systems with lower coverage. And we would see that this, from the GF point of view, we built on developing GF into bigger and bigger tasks and coverage, whereas much research in mainstream machine translation based on neural networks, for instance, tries to improve the precision. And there is, of course, a GF way to put this together. So we had this colored translation where we had a semantic precision grammar backed up by a wide coverage syntactic grammar backed up by chunks. But if we compare it with what is the state of the art in neural machine translation or earlier statistical machine translation, so one of the reasons this was not so encouraging was that we were ended up with a lower precision in this wide coverage scenario than the statistical approaches. But so part of what can be done in GF is more development and research, but there are even practical needs for research in this segment that we are targeting, which is that we said that well, we want to get down from PhD in linguistics to bachelor's in computer science when doing grammar writing, but this can still be too demanding, too expensive, and therefore there is ongoing research on automating more of the grammar writing so that you can build grammars even faster and partly automated. And some ingredients of this is concept alignment, which is a kind of a machine learning approach for extracting grammar rules from parallel texts. And Arianna will talk about that later. Then also APIs, for instance, RGL API, but also higher level APIs for semantic structures for natural language generation. That's an active area. That's for grammar writing, and then for input when you are actually, for instance, translating or interpreting some natural language, then we need some kind of robust parsing to interpret input, which can be out of the grammar, but it can be something that is still makes sense if you adjust it a little. as a special case of this authoring help. So if you want to create a multilingual document, for instance, a product description, and disseminate it in different languages, so then you typically create a master document, and you want to do it in such a way that it is in this CNL, controlled natural language, and make it easy to, almost as easy to create a CNL document than it is to create an ordinary natural language document. So both of these are research issues, and some techniques of these are hybrid. So you can use, for instance, neural parsing as a front end to GF. So you get this interlingual tree out of neural parsing, and then you generate text from that, and you can there have, as a part of this, some machine learned translation rules. Another view on this, which shows that this is promising, is that you actually, once you have a grammar, so you can generalize the observations that you have made with statistical methods by just looking at the data. So if, for instance, you know how you translate "this looks good" to German, then you can immediately, by the grammar, generalize this to dozens of different variations of the same phrase in different tenses and questions and so on. All right, so that was the research things. Another thing is that is important for GF is that it is not a kind of a sect or a dead end, but it has interfaces to other formats, so that we actually can both use information from other computational linguistics format, and also that we can generate those formats. So one of the most important formats here that is heavily used since a few years is WordNet and multilingual WordNets, where we want to interpret the sense mappings in the WordNet as translation rules. And Krasimir Angelov will probably talk more about this. There is FrameNet, which goes a bit beyond this. It's related to WordNet, but goes to more complex combinations and constructions of language. Has also extensive GF bindings. Abstract meaning representations goes into a more, let's say, semantic level. And this is one of those things where actually GF has been able to do well in these shared tasks or competitions in mainstream NLP, with this work by Normos, Grositis, and others. Universal dependencies is another very relevant format or approach related to GF, because it's a dependency tree format where you have the same labels, the same representations for different languages. And this is closely related to the abstract syntax trees in GF. And I will talk about more about that next week. So this is another UD thing. Then in the dialogue systems, when you are building a kind of limited dialogue systems, you might want to have a language model that is based on a grammar, so that it helps create or choose the right interpretation of the spoken text. And for instance, the radar system from Saab that I showed before was built in that way, by using the GF grammar and then the derived speech recognition format. So Of course, GF is also an academic project, so there are publications. Some of them you can directly find by Google Scholar search, but then of course you get a better recall if you if you know some of the authors and look at their publication pages. The GF book with translation to Chinese, which maybe some people in this summer school would prefer to the English version. The resource grammars are typically also published nowadays often as master's thesis, but also often as derived conference or journal papers. So that's something for you participants to keep in mind. So if you this is one way to obtain a publication or a master's thesis or both, is to work on the resource grammar for a new language. And sometimes the languages are more demanding, so it actually extends to a PhD thesis rather than a master's thesis. It depends a bit on how much resources you have to start with on the language. So there have been a number of theses. So this is from till 8 years ago, and this is after that. So you see, for instance, yeah, there are different topics here. Okay, so we are almost done with this. So there are a couple of visions that I would like to finish with. So one is cabbage. So it's something that Inari and her colleagues at Singapore here have been working on, which is an format for legal documents and kind of building up computational law together with the texts automatically by using a controlled natural language with grammatical framework. And I already showed some other applications of computational law, for instance, the GDPR. So this is actually a big and promising field where controlled language precision grammars is could be make much more use and could be useful and have impact. The other theme, so Meng will talk about that next week. And the other thing is the abstract Wikipedia. That is our special theme. So in today's Wikipedia, there are about 20 million topics and 300 languages. And if you want to have all the topics available in all languages, you need 6 billion articles that someone has to write. But together with this NLG, where you have a kind of a master document in some kind of an abstract representation, then you just generate each language from that, and you can change the multiplication to addition, which gives you kind of 2 orders of magnitude reduction in the work that is needed to maintain the Wikipedia in all of these languages and make all information, all knowledge available in the languages. So it's based on this interlingual approach. And the originator of this idea, Denny Vrandecic, will talk about it tomorrow. And I will also talk about next week about some of the first steps into this kind of natural language generation. So we conclude with the summer schools. We have had 5 every odd year. Stellenbosch was an outlier because summer is on the southern hemisphere is not in the northern summer. And this year is also, of course, a bit exceptional because of the pandemic that moved the summer school from last year to this year. And that in Singapore, probably the season doesn't matter so much because it lies almost on the equator. So here, to conclude the ecosystem, this is my last slide about that. Thank you for listening. I think, yeah, I spent 50 minutes on this, and now I think we deserve a break of some 15 minutes. Of course, well, I can first take some questions if you have them right now. You can also write questions in the chat during the break, and then I will answer them before we get to the next topic, which is that we actually start looking at GF hands-on. But let's have a break until...
Excuse me?
Yes?
I wonder if you could say a few words about the difference between GF and Haskell programming language.
Yeah, so a few words. So GF has many of the same structures as Haskell, for instance, functions, higher order functions, algebraic data types. But then it also has some special things like regular expression, pattern matching. Well, Haskell also has libraries for that, but in any way, the module system is a bit different. But the biggest difference is that GF programs are reversible. So when you write a function as a linearization function, then you can always also get it as a parsing function. And if you write linearization or NLG functions in Haskell, then that doesn't happen. So it's a restricted functional language in that sense.
What properties of GF makes it reversible?
Why is it reversible?
Yes, what properties in the language makes this reversible property possible?
Yeah, so it's basically recursion is restricted in a way that it. I think the place to go to all of the details is when we talk about the PGF, the format. But we want to. One thing is, for instance, that there is a finite number of words and tokens that has to be done, that has to be known at compile time of the grammar.
Yes, I see. So, very interesting.
Yeah, so I think it would be, it's a very good question, and I think one should try and find new answers to that from time to time, because it's, I also, sometimes I just speculate, and also with some colleagues who are into functional programming, so how one could use this reversibility in some other functional programming applications, because it can be interesting to have computation that can be run in both ways. That was actually one of the secrets of Prolog programming language, or a secret of that its popularity. But in GF we haven't kind of used it for anything else than language.
I think I've heard about this reversibility idea being investigated in computer science somewhere. So
yeah, so there has been, yeah, so it is an existing topic, but yeah, we have.
I'm using that property for testing in the work I did for my PhD, because the idea is that to generate an exhaustive list of test cases is possible, much more feasible in GF, because of this reversibility property. But maybe this is a bit too technical to go details in this bit.
Very good example. Okay, I'm curious about the ambulance example. Does a project like that involve a lot of tree traversal? Yeah, so it does require tree traversal when you choose the phrase from the menus, but we have tried to build them in such a way that we minimize the tree traversal that is visible to the user. So, but that's one of the tricky things if you have a big grammar, so you want to make it maximally easy and natural to build even a long tree. So that's in some sense a research topic. Okay, but I think I need to get some coffee or something, and we'll meet again at whatever time zone, but 15 minutes from now. See you soon again. Hello again, welcome back. Hope you have grabbed something to drink or whatever. Are there any questions that we should answer before we go to the next topic? Well, the floor is open whenever you want. Let me now share my desktop actually. So you see my browser here.
Yes.
Do you see? Yeah, okay.
And your Emacs.
Yes, so that's on purpose. I want to show many things at the same time. And the way I usually find to GF is through my own web page, but you might have some other ways of doing it. And now I will talk about two things. First is the GF Cloud, and then the other one is the GF Shell. And these are different in the sense that the GF Shell and associated software has to be downloaded from here and installed on your computer, whereas a GF Cloud you can just use by clicking here. So there are a few demo-like things here and documentation how you write cloud applications yourself. So that's also something that can be interesting to some of you if you are experienced web programmers or want to become ones. But I would first like to show the kind of one of the most characteristic demos of GF, the minibar, the word completing translation tool. So it looks as follows. So I said that GF is reversible, and it means that when you have written some rules, they can be used for both generation and parsing of language. And the parsing is moreover incremental. So that is something that helps the user to write texts and sentences that are actually recognized by the grammar. So it can always give you the next word or the continuation of the next word. And one way to represent it is in this format where you have a list of the possible next words. Here it's the first word, and it's taken from the resource grammar demo as shown here with the start category CL for close from English. So these are all the words that I can start my clause with. And I want to now construct a certain clause. So I say I start with the word this. And let's say what happens then. So you get a different set of words. So you may recognize that these are similar to the so-called fridge magnets that you have on the fridge door, where you can build poetry. And that was the inspiration of this demo and this front end to the GF parser. So, and the name minibar is kind of a second version of the fridge magnets, which was a bit smaller than the first one, I guess. That's why it's minibar. But anyway, so these magnets are dynamic in the sense that when you have, after each choice, you may get a different set of magnets. Okay, so let's continue with this grammar, kind of self-referring example. So this grammar, and now you basically have only verbs that can continue. So let's take one of the simplest verbs, is. It could also be this grammar in something is or whatever, but let's take is. This grammar is very small. Now, what happens when you have completed this? You get a tree which is translated to different languages. And in the middle, there is an abstract syntax tree. This grammar, very small. And you see that this tree is abstract in the sense that it is built from, although this looks like English words, so it is actually built from abstract syntax objects. This determiner, grammar, noun, very, adjective, and small adjective, which are combined into a tree, following the rules of the abstract syntax. I will come to that later. You also see that there is no copula here, so the word is not a part of it because it's not something that belongs to the interlingua. Some languages don't, for instance, have any copula, but they just put together this grammar and very small without any verb. Okay, there's also another view of it which shows the types of each subtree that starts at that node. The other thing that you can see here is syntax trees, concrete syntax trees for each language. So let's take the English because it's something that we all understand. So here we can first of all see a dependency tree. So those of you who are familiar with dependencies, and in particular universal dependencies, will see that this belongs to the universal dependencies. And there is a very short distance from the GF abstract syntax tree to a dependency tree, so we will see that later. But you can also see a concrete syntax tree, also called parse tree or a phrase structure tree. And this tree is like the dependency tree, so those are different for each language at the same time as the abstract syntax tree is shared. So if you take the tree for some other language, just pick something at random. So, well, this looks, I think, pretty much the same. But you can look at each of them if you want, and then you also have yet another visualization, which is word alignment. So it is here shown alphabetically from one language to the other. And you already see in this simple example that the word order and the number of words can be quite different in different languages in this set of languages, which also shows the power of the abstract syntax, that it can actually abstract over all of these language differences and generate correct linearizations in each of them, correct modulo to the correctness of the grammar. So almost every time I show this demo, there is still someone who finds some error in some of the languages. So you are welcome to report those. So that's the interactive parsing, or the completion-based incremental parsing. You can also generate random sentences or clauses, which sometimes make good sense, and sometimes they don't make any sense, which is also a kind of an feature of this grammar, that it's an resource grammar. So that's the term that we use for grammars that just work on the surface, or on the syntax level and don't care about the semantics. So you get kind of any words, you can combine them as long as you do that in an grammatically correct way. And of course, if you are a poet or someone, then you can always find some interpretation or use of that. So that's also kind of a feature of natural language, that whatever nonsensical things you can imagine built with the grammar, so you can always find some context where that would make sense, or some interpretation under which it would make sense. Yet another thing which is, you can see here, is this little arrowhead. So when you click at that, you will get different translations of the same. No, sorry, not translations, but different forms of the same clause. So this is a kind of a generalization of inflections of the word. So you can actually build an inflection table for almost any syntactic unit, even if it is a long sentence, which puts it into different tenses and negation and question or declarative or something like that. That's a very powerful feature of this kind of grammars which I showed in this generalization slide, where if you know how to, for instance, translate one such combination of words in some tense, then you know all of the other, you can even infer all of the other translations as well. And maybe you wonder what these language flags here are. So let's go back here. I'm sorry, this was stupid. So I lost them, but you can see them here. So you can see that there are these links to available speech synthesis, so you can get.
The names have been here. The names have been here. The names have been here. The names have been here.
The names have been here.
Okay. Well,
the names have been here.
Maybe useful for some language training purposes if you use the grammar in that way. But now, so I will show another grammar very soon. I will first change the start category so that I can also build a question. And I write I write the following sentence, the following question. Is your wife here? And you can see the syntax tree that is quite complex. So it's an utterance which is built from a question, which is built from a question clause in a positive polarity simultaneous present tense, which in turn the clause is has a subject which is a common noun with a determiner, where the noun is the possessive of you, the plural you. Actually, that's one of the rare interpretations. And wife is a noun, and here is the predicate, like being here. Okay, so you have like 7, 10, 13, 15 nodes in this syntax tree, and this is just shows the kind of the detailed syntactic structure of the sentence, the way a linguist would do it. So we can also look at it in the more familiar linguistic tree. Something that is actually interesting here is that you get a crossing link because is here, they belong to the same verb phrase. And again, this is no problem for the parallel multiple context-free grammars. So that's how it looks like. But you get this syntax tree, which shows the kind of the linguistic detail structure. And this is what you get in the resource grammars. Also, the categories here are linguistic. So you have common noun, noun phrase, verb phrase, and so on. But now we look at the same sentence in another oh, sorry. Yeah. I think that was not what I wanted to do. I wanted to show a bit different. Let's do it again. Is your wife in the restaurant? Okay. And then look at this again, and you get an even bigger tree. For instance, here you can say in the restaurant, but there is nothing that prevents you from using some other preposition like is your wife from the restaurant, or is your wife with the restaurant, or without the restaurant. All of this is syntactically possible, and you see all of the structure here. But now, as I promised, I will take this to another grammar, which is called the phrase book. And I write is your wife in the restaurant? And I could also add a question mark here. And what I see here, so I also see translations. Probably they are the same as before, but I'm not completely sure. But anyway, so if you look at the syntax tree, so it's much simpler. Because here we are not using a free syntactic grammar, but we are using a semantic grammar. If the syntactic grammars are called resource grammars, so this we call an application grammar. And the application here is a tourist phrase book, as the name tells us. So you are not interested in all possible combinations of words, but only something that is relevant. So you have a question which is built on a proposition with an action being in a place, and this is applied to a person like wife, and then someone's wife, and then the place is restaurant. So for instance, you can't change the preposition here, because when you are being in some place, so then what the place is will determine what the preposition is there, which of course it's a better guarantee for natural idiomatic language than if you, for instance, say in the resource grammar you could say is your wife on the restaurant, but that's not something that you can say here in the application grammar. But you can say is your wife at the station, because station, as I have been told, requires the in English the preposition at, whereas restaurant the preposition of being there is in. So this is the kind of things that you are usually ultimately interested when you are building GF applications, where you have a more restricted language and which has a certain purpose or a domain, and those we call application grammars. But then the resource grammars are a kind of important infrastructure because they can be used as libraries for building these. And that's what we will enter now. Let me show one more thing, which is that also the phrase structure tree now becomes a bit different when you when you are using this grammar. Also, at this point, you no longer have a dependency tree, because there's just no mapping from these semantic structures to the dependency trees at the moment. Of course, one could build that as well, but the philosophy of dependency trees is more closer to the to these resource grammars than to the application grammars. Okay, do you have questions about this part? Because now I will enter the business of actually writing grammars. So we go back to the cloud service and then click at GF Online Editor for simple multilingual grammars. And we start a new grammar and we call it GFSS 2021, so that you can easily find it later. And what do we want to do here? So actually my plan is to build a part of this phrasebook as an application grammar and see what is needed there. And we start with a Hello World program. That's also what Inari did in her tutorial this morning. But I think I can do it even simpler. So I will just start with one category, phrase. Let's call it phrase. And then we have a function which builds a phrase. And here I also do a bit differently from Inari, because I want you to kind of, I want to force a certain convention for naming from the beginning. Naming the abstract syntax function. So I would call it hi phrase. And the structure here is that this function will be just a word, and it will be of the category phrase. So then I use the English word hi, and then an underscore, and then phrase. Okay. Okay, so then you have to say that this hi phrase is actually a phrase, which looks a bit superfluous now because you can see it from the name, but of course GF can't see it from the name, I can see it. But it makes it kind of easier to keep a consistent naming in the grammar, because there can be different words that appear in the same category, for instance. So this is the simplest possible abstract syntax. It has one category and it has one function in that category. Not a big deal, I would say. But then the next thing is that, and it's a bit hidden, so there's a little, if you hover here, you find a little plus and you can add a concrete syntax. And let's pick English here. And it gives me a template of what I have to write. So I have to write in the abstract syntax, I have categories and functions. So categories are kind of classes of trees, and functions are ways to construct objects, or in these classes, or ways to construct trees. So here we can only construct one tree, which is hi phrase, and we linearize it into a string, which is again the simplest way to linearize something. Almost corresponds to context-free grammar without this parallel multiple thing. And the string is hi. And now I have a kind of English grammar. I can compile it. Let's see what happens. So it says okay. It compiles without an error. But I can also already now see it in the minibar. So there is only one magnet to choose from, and it's high. And when I have built that, it gives me one abstract syntax tree, which looks quite simple, and then the phrase structure tree that looks like this. And probably the word alignment doesn't show me anything interesting here. Okay, so let's go back to the editor, and now we can work in 2 dimensions. So we can either add phrases in the abstract syntax, or we could add more languages. And I think it will be more interesting to add more languages once we have at least some more phrases. And now I take the same as what Inari did. Well, if you didn't see her talk, that doesn't matter. I will reproduce everything here, or everything that you need. So there's a plus here, and I can add a more another category, recipient. And then I can add something that we need for hello world, namely we need world. And then we need some way to combine hello and world. So we could have something which combines a phrase with a recipient, so that we could create hi world, but that would also give us hi world and hi world, and that's not what we want. But we introduce another function here called hello, and I call it hello recipient phrase. A bit long name, but when you see the name, so you know what this is doing. And notice that there are no underscores here, because I'm not. This is not just something that gives you some words, but it is a combination rule, so to say, which takes a recipient, builds a phrase. Okay, you see the syntax here. So you have the name of the function, then you have the colon, and then you have the category. Likewise here, but here you have an argument, recipient, and a value phrase. And this notation is, of course, familiar from functional programming languages, in particular Haskell. But it's also GF notation. So what do you do with this now? You need to linearize the new things. And we go to English, and then the editor has created for us new tasks. So I will say that also recipient is a string. And world recipient is world. And hello recipient is hello plus recipient. So you might be tempted to write plus, but you get a nasty error message for that. So I rather write plus. That's also what comes from Haskell notation. And it means actually that you will see that those two things are treated as separate tokens. So hello is one token, and then there's usually space and then another token. All right. So now I go to the minibar again, and I get, there are 2 ways to start a sentence, hello And if you start with that, then you get world, and then you can build hello world. And what is the tree for that? Then it's, of course, you have applied hello recipient phrase to world recipient. And if you have look at this syntax tree, so actually it has also already a branching. So there's a phrase built from hello plus the recipient world. And you can also spell it out in some of the English variants here. Now we can immediately make this multilingual. So we go to the we have the English grammar open, and we add another language with plus. Let's take Italian because it has some, yeah, I think it's a good language for demos, because people usually understand it even if the words, even if they don't know Italian. So for instance here, I will try ciao is like hi, and word is mondo, and then I don't know any other, well, there are some other words for ciao, but for just for the sake of illustration, so I use, unlike in English, I can use the same word ciao in different places. Now, if we go to the minibar, we can see that in English we can start with in two ways. So we can say hello world, and then when we have done it, so we get this translation into Italian. So with the word alignment, or we could also start from Italian. And of course, what happens then is that we only have one word to start with. And then it either gives us the complete phrase without any completions, or we can add mondo, and then we can't continue it anymore, but we get this hello world or ciao mondo. So these are the very basic things I wanted to start with. So we have now a hello world example, but now I would like to introduce some more interesting phrases from a linguistic point of view. So I want to say something about some facts. And let's introduce, first of all, a new category called fact. And what is a fact? So we would say, like, a fact that this restaurant is Italian, okay? And what are the ingredients of this? So we have this restaurant, which is a subject, and then Italian, which is the predicate, or is Italian. So we have fact, which connects some object with a property. And the object in the what I mentioned was this restaurant, but you could also have those restaurants, and that's another object, and it has something common with this restaurant. So let's not take those as separate things, because otherwise you would have a quadratic explosion of atomic functions. Let's say if you also have hotel, if you also have bar, and you have this and those and these and so on. So you want to analyze this in a linguistic way into a determiner and a noun, and we call them, because we are now working in a semantic grammar, so we don't call them with this linguistic terms. What we call this object is the, like this restaurant, and the object is of some kind. Okay. And let's put now make some functions that combine them. So I will write first of all that the phrase can be a fact. Notice that previously a phrase could be a greeting, which is built directly as a phrase, but now we want to have a kind of intermediate category of facts, because we want to use the, can already reveal it, so we want to use the same facts also for questions and not only for statements. Is that restaurant Italian or good or whatever? So fact phrase, and then we want to build objects from kinds. So we have this kind is from kind to object, and then let's have some kinds here. So restaurant kind, and now this is just a simple word, so I use the underscore, and then we have property like good. Okay. So what happens when we go to English? So this should be quite straightforward. We are still working with strings, although this will soon shown to be intenable. Property, and then fact phrase is just the fact, so nothing happens to the fact when we use it as a phrase. This kind is this plus kind. Notice, so here you have the kind and the fact with the small letters are now variables that are bound on the left-hand side of this equation. So this kind of kind applies to any kind. Here we just have one kind. Restaurant, and good is good. Okay. So let's see what happens in the minibar. And now the same thing should be added to the Italian, but I will wait with that, because actually I think I will take the Italian away now, so that it will not disturb us. Okay, so what happened here? Let's see. I have phrase. This. Oh, yeah. So I think we did something wrong here. No, it's kind to object. Fact phrase. Oh, yeah. We had forgotten something, so we can't still build any facts here. So yeah, that was the problem. So how do we build a fact? Of course, we build a fact from object property fact, object property to fact. Okay, and now we have to add its linearization. Object is property. And here maybe you start to see that this will not be very scalable because we sometimes have to say that object are property. But let's not care about it yet. So now when we go to the minibar, we can see this restaurant is good. Okay. And that's the kind of the new kind of phrase that we can form here. So we don't have terribly many new phrases yet, but now we can soon explode it by just adding a few more kinds and properties. So we have to add them in the abstract first. So let's say car, kind. So let's add some negative things as well. And let's say Swedish. Okay. And then finally, a new rule for saying that we can also say this Swedish car is good. So then we add a property to a kind to form yet a new kind. So we call this say property kind. Add.
Your Dutch and Swedish are wrong in wrong category.
Ah, thanks. Yeah, I will change it. You are right. And also, yeah, both of them. Thanks. Dirty property and Swedish property, and now let's go here. So update it to the task that we have to face. Car, hotel, dirty, Swedish capital letter, and then finally so here no new word is introduced, but it's just property plus guide, and then go to minibar, and then we can generate some new random things. Why can't we get yeah, this Swedish car is good. Okay, so that's what I wanted to have. So let's look at the tree, and you can see that it's built from these functions that we have here. And if you want to see, but now it's actually trivial, so you can always reach the type of each subtree from the top node of that tree. Yes, so I think we deserve a break again. So let's have until 1:15 and continue after that. Okay, welcome back. Let's continue a while more with this cloud-based editor for grammars. So we have now the abstract and the English grammar, and I promised that we would also be able to form questions, and now we want to form them from the same facts. So we don't want to have a separate set of rules for forming questions and declarative statements, but whenever we have a fact, we can both have it as a statement and a question. And this means that when we have here a way of building a phrase from a fact, so we call it a fact phrase. So let's add another one, call it a question fact phrase. And now we have to look at the linearization. And the fact is now something like this car is good. So how can we form a phrase from that? Well, we form it by moving is to the front, right? Is this car good? But how can we do it? So we have already built a string. This car is good. So there is no way to take the is apart from that string. And we are led to the first feature of GF as something which is more powerful than context-free grammars. In context-free grammars, you just combine strings, but in multiple context-free grammar, you actually can combine tuples of strings. And here we want to have fact as such a tuple of strings. So we say that it's a record that consists of two strings. So there is this subject part and the let's call it the predicate part. So let's say it's a subject and there is a predicate, which is a string. Okay. Now we have changed the type of facts. We have not changed the fact forming rules here yet, and we have not yet told how to form question phrases, but let us see what happens when we compile this. Because then we actually see an error. So we see actually two errors. So one is when we build the object property fact, and we have said that it's object plus is plus property, and it was expecting two strings in a record with a predicate and the subject, but it inferred that this was just a string. Okay, so we have to change this. In the same way, in the fact phrase, we were expecting to build a string, but since we knew that the argument here is a fact, so we also know that it's a record, so we did not have a string there. So now we have to fix both of these things, and when we know how to fix them, so we at the same time know how to build the question phrase. So object is property. Let's take that. So then we actually, it's enough to say that subject isn't the object and predicate is the property. Okay. And now when we build the fact, then we take the subject part of the fact and the word is and the predicate part of the fact. Notice, so we have used this dot notation, which is quite common in different programming languages, where we take projections from a data structure, such as a record. This is, by the way, something that Haskell doesn't have as a standard, but Haskell has records, but they work in a different way. So this is known from many other programming languages. And here we do almost the same, but we put then is in front. So let's see what happens now. We compile it. Okay, no errors. Actually, when we go to the minibar, so it also compiles it. So it's actually a superfluous step to compile it separately. But when we go to the minibar, so we have this Swedish car is good. Let's clear this. Now we can also start the sentence with is. Is this good hotel dirty? If anyone wants to build such a question. And now we see that we have, instead of an fact statement, we have built a question from the same fact, this object property fact. If we look at the parse tree, so it looks, of course, as is expected. So that was the first example of using something more than a context-free grammar, something more than strings in GF, and that was the records. Then I will take the step, yet another step, because we only need one more thing in order to get the kind of the full power of GF, and that's called tables. So so what is that? It's when you want to inflect words. So if we add one more object building, actually this should be called, if we are consistent, so we call this kind object. Sorry for that. But let it be for the moment. So we have another function that we call those kind object. Goes from kind to object. Okay. And then we linearize it to but of course now this compiles, but the grammar is not correct. So if we form those restaurant is good. So that's not what we want, because we would like to have those restaurants are good. So we have to be able to inflect the noun restaurant, restaurants, and the verb is, are, so that they are moreover in agreement. So whenever the one is singular, also the other one is, and whenever the one is plural, then also the other one is. That's called agreement in linguistics. So let's see how we do that. we need now one more rule, which is to enable us to distinguish between singular and plural, and we call it, sorry, number, which is either singular or plural. Those will, with Haskell knowledge, would recognize this as an algebraic data type definition, where you define a new type, number, which is has these two values, singular or plural. And actually, one difference to Haskell is that in GF we keep all of these parameter types finite, and that's one of the reasons why we can keep the grammar reversible. But that's a technical question that we can leave to a later discussion. But anyway, now here it is enough to have a number, and it only has two values in Swedish, sorry, in English and Swedish as well, singular or plural. In Chinese, you don't need anything at all, but in Arabic, you would need both singular, plural, and dual. Those things we will see later. But now it's enough to look at this two value, singular and plural, and what it affects is the linearization of kinds. So we want to say that the linearization of a kind depends on the number. In such a way that, for instance, car is, and now we use yet another notation. So notice here, we use a double arrow when we have a function from a parameter type to a string. So this is kind of a special kind of a function where we can enumerate all the different argument value pairs in a table. So let's call this, let's now build such a table. So it has a keyword table, which for the singular assigns the string car, and for the plural, the string cars. So now we have done part of the things that we want to do. So what remains to do is to do the same for hotel and restaurant, and then to use it properly in the rules. And now we are getting into kind of a bit more complicated and involved linguistic programming. Still quite simple compared to the full situation, but you will get a flavor of it. So we have to make sure to implement all the linearization rules in such a way that these types that are defined in the linearization linkat definitions are obeyed. So if we now try to compile this, we get lots of errors, quite a few of them. So those kind object, there was just a string found or expected, but what was found was a table from number to string, and the same repeats for many places. So the first thing is to build the singular and plural forms of each of the kinds. And we could, of course, write these tables explicitly. And this is still doable in such a small grammar. But we want to be a bit more clever, and we write an operation, an auxiliary or helper function, which gives us a regular kind, which from one string forms a table from number to string. Okay. And we define this as something that is a function that takes a string S and then builds a table where the singular is S and the plural is S plus the ending S. So you see there's a bit of an acrobacy here with the S, so it's used both as a variable, and then when it's in the plural ending, it's in quotes. Of course, there is no confusion because the expressions without quotes are variables or functions, and the ones within quotes are literal strings. So we have this rec kind, and now we can actually go to just add this rec kind everywhere that we need. However, I think, and you can see we are not done yet. So if you compile this, we still get errors. So those kind object and this kind, we again get an error having to do with the discrepancy between a string and a table. And also in property kind. So now is where we actually use this property that the kinds are not just strings, but tables from number to string. Namely, when we have this kind, then we use the singular form. So from a table, we select the form with the bang operator. So kind bang string is car, and kind bang plural is cars if we apply it to the car kind. And here this plural. Are we done now? Let's ask the compiler. No. Property kind. There's again a discrepancy, and notice that this is a bit more complicated because we are now combining two things. And the thing is that we are forming a kind, that a kind should be a table from number to string, but here we are just building a string. So the way we solve this is by saying that we have a table which for any number n, we could also write something like this. So let's start with this. For the plural, it's property plus kind plural. Okay. We compile it, so now it's actually okay. So we have built a table from singular and plural to the corresponding forms. But now I would actually like to make this nicer at once, because we don't always have to write all the branches in a table explicitly, but we can use a variable. So saying whatever the number, then the number is passed to the kind part, and then you get something of the correct type. So when we compile it, it's okay. And we go to the minibar, we clear this, and then we say those. Then it actually gives us those restaurants. We still have to deal with the copula is, but let's take that as the next thing. First, just look at that those dirty cars. So actually the agreement goes even over any number of adjectives in between, and this is what we wanted. So what remains to fix is the is and are, and it appears twice here. So maybe you actually want to fix it once and for all, and there are different ways of doing this. So you have now subject and predicate. But actually the predicate consists of two parts. So there is both a verb and a complement in the predicate. And we could maybe just take those three apart. Or we could have them in one record. So we can say the predicate consists of a verb and the complement. So we have a nested record here. And when you have a fact phrase, then so fact pred doesn't exist anymore, but we have the, well, it does, but it's not a string, but it's a record, but we just have it as the complement. And then here we have fact pred verb. So it's subject verb complement. And here it is the other way around, fact pred complement and here fact pred verb. Okay. So where does the fact pred verb come from? We have to add it in when we are forming a fact. And where is it? We are forming a fact. It's here. So we have to add it here. Predicate complement is the property and verb is and we use the verb be verb. Okay, so where does the be verb come from? Maybe we need it in some other cases as well. And the be verb is, we define it here. We define it as a table from number to string, of course, in the same way as for nouns. So for singular it's is, and for plural it's are. And what remains to do here is that we select the correct form of the be verb here, and we get it from the object in some way. Okay, but the object is now just a string, so it doesn't have the number. We have to add it there. This is getting complicated, but that's on purpose. Well, the purpose is to show how you program in GF, but then the purpose is also to show in a while that we want to do this as seldom as possible, because it really even the simplest language like English, in the simplest grammar, you get into quite complicated linguistic considerations. So we say that in the object there is a string s, and then it has to remember its number. And what else? So here we have to remember, when we form an object, we have to remember the number, the strings separately. I'm sorry, n is a singular. And here the same thing. And now, since we have remembered the number, we can, here you see that the subject, we need to take the S part of the object for the subject, and for the predicate we need to take the be verb in the number part. Sorry. Are we done now? Frankly, I'm not sure. Let's try the compiler. Ah, there's an error. Syntax error. Where is that? So now I would actually really love to see the. I'd really love to see the line numbers which are missing here, but I know that I can see it, that it must be here. So there should be a colon and not an equality sign here. What else? Constant not found, be verb. Okay, so that's easy. Be verb, it's be underscore verb. What else? Okay, now we go to the minibar. Those dirty Swedish cars are good. And then we change, we can also do this. We change those to this. Then we can get this dirty Swedish car is good. And now we have done the subject verb agreement in our English concrete syntax. We have also done both questions and statements, and now we can, let's see if we can, no, we can't change this, but we can change this into those, then it gets are those Swedish cars dirty. Now, if we want to do the same thing for Italian, I can just tell you that you have a couple of more things to take into account. For instance, you also have the gender agreement, not only the number agreement. So car is feminine and restaurant is masculine. Then you have 4 forms of the adjectives, both masculine, feminine, and then singular and plural. We also have something with the place of the adjective. So if you look at the GF book, for instance, or the tutorial, it explains how to do the same thing for Italian with all the parameters that are needed. But now we draw another tool from the GF hat, which is the resource grammar. And we do this by using the library. For Italian. And we sorry, what happens here? I'd like to open the resource grammar. Why doesn't it show? Show the opened library list. Am I doing something wrong? Well, let's not think about that right now, but let's do two things at the same time. Namely, I show this grammars in the text mode. And the text mode adds the semicolons and some other things that are needed here. And then I continue the work in the text editor and the GF shell. So this is my abstract syntax, and then I take another file for the English. In the text mode. So even if you start your development in the online editor, you sooner or later have to, when you scale up the grammar, so you will have to switch to the normal editing mode in the text editor and the GF shell. I guess the same is true of the Jupyter as well. But let's see. So now I am here and I have these two grammars here, and I go to GF, and now I have to do a bit more work than in the that you get for free in the editor. So I have to import the grammar. It's compiled and it's here, and then I can, of course, I can parse. And now the incremental features are given by pressing the tab. This dirty car is Swedish, and I get the syntax tree. I can also get the random generation of a tree, and if I can pipe the tree into linearization. And something that I don't have in the in this cloud-based editor is that I can get all the trees down to a certain depth, actually, because we could add adjectives. Let's see if that's 5. Yeah, so then we can get combinations of adjectives, and of course there are already infinitely many phrases I can form here. But anyway, so now the idea was, and I think I still have time for this, was a bit slower than I had thought, but let's take the Italian. And I do it now in a different way, namely I take the English, but then Italian. The coding flag is basically not needed anymore, but let it be there. So it used not to be the default coding, but that was a long time ago. The more important thing is that I can now open the resource grammar library of Italian, so syntactic and paradigms. And then I can get started with something here. So let's see, I for the moment I ignore the phrase and recipient parts, and let's just look at how the agreement things work on the fact level. And we do this in a very simple way. So we choose the facts to be of the category clause. That was the category that I showed in the first minibar demo with the resource grammar, as you might remember. At this point, it's actually useful to have the resource grammar API available. So let's go there. I should update this link. And we see how we can form clauses. So we can form them in many different ways, but we can in particular form a clause from a noun phrase and an adjectival phrase. So that's what we want to do. The objects will be noun phrases and kinds will be common nouns. Properties will be adjectival phrases. And we ignore these things now to concentrate on the agreement things. So the fact phrase, oh yeah, so we don't have the phrase level at all, we leave it out. But this kind now is a noun phrase which is formed from a CM and a determiner. And what is the determiner? So it can, among other things, be this det. So let's just use that. So we make a noun phrase from this det and the kind. Then restaurant kind is, so it's a ristorante. We need Italian morphological paradigms, so we have many of them, but we will need, most of the time we'll need this regular noun, so it's always called make n, but we have to lift it into a CN so that it's a phrase rather than just a word. And I promised you that Italian is easy to understand, so it's ristorante. Adjective is an adjectival phrase formed from the adjective buono. Object, property, fact. And now you can see something which is really more simple than we had before. Namely, we just make a clause from the object and the property. Because we can make a clause from a noun phrase and an adjectival phrase. Car is macchina, and hotel is there are many words, but one is albergo. Is sporco. Vedere. Property kind. So then you just have to take a common noun and modify it with an adjective, and this you actually have here as well. So whenever you want to build something in some category, so you will find some make MK with that category name, and then you take just those. the arguments. Questions we didn't consider yet, and those is similar to this. That. And all these parameters and operators, we don't need them anymore because all of this is inside the resource grammar. So let's see if this works now. Maybe I have done something wrong, but oh yeah, where is that? It's in restaurant in KM. Okay, and now I can parse in the category of clause because, no, sorry, in the category of fact, which is what I have now, parse in the category of fact and in language and this Swedish car is dirty. What was happening here? Now I understand what the problem is. So the fact is not a string. So basically I have to actually build the phrase here, otherwise I will not succeed here. So let's just leave out the greeting. So we have to have kind of more uniform. We have to use more of the same abstract syntax. So it's make phrase. So this is called phrase from the sentence made from the fact. So let's introduce Italian again, and now I parsing this Swedish car is dirty, and I translate it into Italian by linearizing it into Italian. And now you see that everything is in feminine singular. And if you have those Swedish cars are dirty, then it changes both, well, in many places. And then if I have it hotel, okay, then it not only gets the gender and number right, but also it has this special form quelli for nouns starting with an vowel and so on. So I think I'm almost used up my time now, but now you could, a possible exercise for you would now be to make a copy of this grammar. I will put it in the GitHub at once, and then just change the words here and see that it will work for your language almost out of the box by just changing the words and changing ita to whatever language you want to address. Well, maybe not everything works quite as it is, but then yeah, you will get something in this simple way. So I can, yeah, I think that my time is up now and I should stop here. But thanks for your patience. Do you have any questions before we end for the day? It's late in Singapore, I know. It's also the end of the working day here, but maybe somewhere else it's not that late. Any questions? Okay, but thanks in that case, and hope to see you around in the coming days and in the coming two weeks.
Yeah, thanks, Aarne. I was thinking we can talk a bit about the logistics of the following days. So like, we're not going to do exactly this same thing. Like, I'm gonna talk 3 hours in the morning and someone else is gonna talk 3 hours in the evening, but we can, if you have suggestions for like what would be the most productive use of these evening sessions. So if you have a suggestion later, just, you know, you can write it on the Discord or email me personally or anything.
Mm-hmm.
Well, I think we're solving an unsolvable problem here. It's you just can't find a good time spot that suits everyone. So me personally, I've made peace with the fact that I'm not going to be sleeping much, so that's okay.
Yeah.
We have to rely a lot on the recordings, I think, many of us.
Well, I was thinking that the lectures next week are probably going to be the types of lectures that I want to experience in person. So probably the recordings, I would rather be there for it, you know, as it's actually happening. So yeah, but that's just me. So that's
yeah. So tomorrow on this same time slot, we actually have a talk by Denny. So that's in that case. So tomorrow, if you want to, like, you want to work on your own project and get interactive help from any of us, so you can do it between basically 5 p.m. Singapore time to 8 p.m. Singapore time. And also, like, even like during the, if you're awake, like if you're in a time zone that you're already awake, like 1 p.m. Singapore time, I will be there in the classroom, and there is not a whole bunch of live students, so I will be also available. So Henry is commenting that the voice quality of tonight's lecture is much better. Yes, so we tested with another microphone today, so hopefully from tomorrow on, the morning lecture will also be better. So would have been good to know that during the lecture and not afterwards. But yeah, that's hiccups for this. So don't be afraid to speak up.
is the lecture tomorrow going to be recorded? The morning one?
Yeah. Everything is going to be recorded. Like all the lectures. Like, we're not going to record just the hands-on session, but like everything that is a lecture is recorded.
Yeah, that's fine. Yeah, I know it's a difficult job. It's an logistically impossible. So I think you're doing the best possible that, you know.
Yeah. So. I'm thinking basically, like, would it be helpful for people to have some kind of like guaranteed slot every day that, okay, so like say that if we say like this 8 p.m/2 p.m. European time, if people would find that helpful to sort of know that, okay, so at this point the Zoom will be online and we can have some kind of Q&A session, or if people would just rather prefer do their own thing and then ask for help in whenever. No. Oh yeah, no one knows. Well, it's just like we have 2 weeks to find out. We just experiment and see how it goes.
Yeah, I'm sure you'll figure out how to organize an online summer school by the end of the 2 weeks, and then the next summer school can be online again, you know. So
yeah, exactly. Yeah, I mean, that would be seriously like a good idea, because if we organize it in some place that is like all places are far away for someone. So it's more people can join if it's also online.
Yeah, it's a new thing, the hybrid events, where it's physically for people who want to be there physically and online for people who don't want to or can't. But it's difficult to figure the sound quality correctly if you want to speak into a room full of people and also have a good quality recording. I think this morning was an example of how it doesn't always work out. So yeah. Yeah, I know it's difficult. Yeah.
Okay, so
For me, it worked when I put the headphones on. It was better, but it's a bit tiresome to have them all the time.
yeah, so the microphone, it was the microphone from the room. Like basically the tech people just like plugged it in to my computer. But then when I switched to my MacBook's microphone, then people reported it, that worked much better. So we're all gonna go with my MacBook microphone tomorrow.
Okay, let's see you again tomorrow then.
Yeah.
It's a shame we can't go for a beer.
Yeah.
Well, it's too early for that. Yes, anyway.
I think, Mikael, you can go for a beer and I can.
Yeah, I will. Yeah, I'll drink one for you. Yeah.
Yes, and at least virtual. Whatever.
Okay, so, well, I'm gonna have to be up and running in 10 hours. So I'm gonna go to bed now. And
Good night. Good night.
good night.